friends, today I will demonstrate how to develop an embedded program for microcontroller 8051 to run a unipolar stepper motor. The student version of Microvision can be freely downloaded from its official site www.keil.com. Here, download the file and follow the simple instructions like license agreement, etc. to install Keil in your system. You can run the software by clicking on the icon. After loading this program, you can see the various menu items on the top row, and the important menu items which we are going to use today are the file menu, the project menu, the debug and the peripherals menu. Now to start the Microvision new project, you have to go to the project and click on the new Microvision project. Now to open a new Microvision project, the dialog box has come and it is asking for the file name. You can give my first project like this, or any other name you can give. Save it. Now the software is asking in which microcontroller you want to make the program. So it is giving a list of manufacturers. Here we will search and see. We want to make a program for 8051. So type 8051 here, 051 here, and give OK. Here the list has come, R8051. We select this. When we select, you can see the full description of the IC here. Give OK. Now it is asking whether this startup.a51 file is to be added to the project or not. This is required when we write a C program, but today we are making an assembly program only, so we will give no. Now we have to make a program file. So for that, go to file, give new. Now the edit window for the file has appeared. Now you can edit your program here. Now I have completed writing the program to run this stepper. The first line of the assembly language program is to move the value 66H to the A register of the microcontroller. Don't forget to put the hash sign in front of the data to indicate to the compiler that it is a data. If you don't put hash, it will be taken as a memory location. Here the bit pattern hex 66 is moved to the output of port 1. A call delay is to give some response time to the motor. RRA is to rotate the bit pattern in the A register to obtain the next sequence to advance the motor to the next position. Now this line is to loop back to the motor run again. This routine will be continuously running, producing the correct sequence of bit patterns to move the motor continuously. Now this delay routine is to generate a software delay to adjust the speed of the motor. The delay can be varied by changing the numbers in R2 and R3 registers. It is asking for a file name. We will give stepper. Stepper ASM. Okay, and you can save it. Now you can see that the color of whatever we have written has changed in this window. it shows that the program has recognized this as a assembly language program. Now you see the source group 1. Here the program is not added. We have to add this program to source group 1. For that, double click on this icon. Now this dialog box has come. Here you give the file name, whatever we have given earlier, stepper ASM. Now you select the type of file. This is not a C source file, it is a ASM source file. You select the ASM. Now you give add. Now it is added. You close this. Now you open and see. Now this stepper ASM is added to the source group 1. Now after completing this assembly language program here and saving it, we will go to the project and we will go to the options for the target. In this, plenty of options are coming. So you can see that the device already we have selected. Target. In this target submenu, you have to select the crystal frequency according to your crystal. So here is 12 megahertz. I am using the same, so I will not change it. You can edit and change if you want. Now go to the output. This is very important. You have to check the create hex file. This column you have to check for creating an executable hex file which you can run in simulations. Here you give OK. Now to compile this program, we will go to the translate icon and press date. Now it has completed the translation or the assembling. It is not having any error. 0 errors it is showing here and 0 warnings. Now you can go to the build and press it. Now the target is built, that hex file is built already without any error. Now you have to go to the debug. You can start the debugging. Now the program is saying us a message that our Keil software is a evaluation model. So it is running with a code limit of a 2K hex file. So it is enough for us. So we will give OK. In this debug mode, you can see all the internal registers from R0 to R7, then the accumulator A register, B register, stack pointer, program counter, data pointer, program status word, etc. While stepping through line by line, you can see the changes in each of the internal register to verify whether it is program is running as per your design. Now I will go to peripherals and IO ports. We are outputting our bit pattern for stepper motor running to port 1. So we will watch the port 1 when the program is running. So select port 1. So the port 1 is visible here. Now you go to debug and run. So when you are running the bit patterns which are sequences required for stepping, the stepper motor is coming here. It's changing. It is according to our design. It is working now. When it is over, you can stop the debugger and you can quit the program by going to file and exit. Okay friends, thank you for watching. If you like the video, kindly give a thumbs up. Also don't forget to subscribe to my channel if you haven't already done.